In this video, I'll cover the sort of questions you should expect to see in Year 10 measurement. If you're following along on the test preview sheet, you can just use the time tags that I popped in the description below to skip to the question numbers that you need help with. Otherwise, just have a look at the description of what sort of question it is, and that way you can find the sort of question that you'd like some help with. Question 1A is asking us to find the area of a composite shape. A composite shape is a shape that's made up of a series of small shapes, polygons, which we know and which we have formulas for. So basically what we're going to do is break this shape down. Now, there are multiple ways of doing each of these questions. Some people will look at this as a large rectangle and take this missing rectangle away from it. In this example, I'm going to do one rectangle plus another one. So the way to start these ones is to first of all find your unknown sides. Okay, there are a couple that we don't know here. So if the total height of the shape is 16 and this portion of the vertical height is 11, that leaves 5, because 11 plus 5 will make 16. If the total width of the shape is 22 and this portion of the width is 7, then that must leave us with 15 here, because 15 plus 7 makes 22. Alright, so what I'm going to do next is I'm going to divide this shape into two rectangles. Now I could go this way or this way. This way looks like it's going to be easier maths for me, so I'm going to go this way. And I'm going to just quickly cross out the information that's going to mislead me, okay? This is not going to be of any use to me anymore, and this one's not going to. Alright, I'm going to call this one area 1, and I'm going to call this one area 2. Again, there are a few different ways of doing this. This is just how I show my working out. So, first of all, I'm going to work out area 1, and ultimately what I'm going to do is then work out area 2 and add them together for the total area. So area 1 is a rectangle, so I know that the formula is the length times the width, which is 7 by 11, which equals 77 square centimetres, because we're dealing with area now. Area 2 is also a rectangle, so it's going to be length by width, which is going to be 22 by 5, and I'm getting these numbers from here, which is going to give me 110 square centimetres. Now, to work out the total area, I just write it as area T is going to be area 1 plus area 2. This line just helps to organise my thoughts, and it also lets my marker know what I'm up to here. So now I sub in my values. Area 1 was 77, area 2 was 110, giving me a total area of 187 centimetres squared. Question 1b is another composite shape which we're trying to find out the area, so I'm trying to find out this area here. Unlike question 1 where I found the two shapes and added them together, this time I'm going to find a rectangle and I'm going to subtract a triangle from it. Okay, so again I'm going to go in and call them area 1 and area 2, and just so this is clear, this is my triangle that I'm working out here. Okay, now I've got the vertical height of the triangle here, so that's going to be useful, and the base of the triangle is going to also be 26.4 meters. So let's get going. Area 1 is going to be a rectangle, so it will be length times width, which is going to be 31.2 by 26.4. Okay, which will give us 823.68 square meters. Area 2 is a triangle, which means we're going to use the base times height divided by 2 formula. So we'll sub into that 26.4 from here, multiplied by 14.6 from here, all divided by 2, which will give us a total of 192.72 square meters. And then to work out the total area of the shape, this time the total area is going to be area 1 minus area 2. So I just sub the values in now. That gives me 823.68 minus 192.72, which will give me 630.96 square meters. In question 1C, we're also trying to find the area of this composite shape, which is a rectangle with a triangle stacked on top of it. At this stage we don't have enough information, so we need to fill in the missing bits. So let's make that a triangle so it's nice and clear, and we need to find out what the height of the triangle is. So if the total height of the shape is 12 and this portion is 8.2, that leaves me with 3.8 meters here, okay? Because 3.8 plus 8.2 makes 12. So let's go in again. We'll call this one area 1. We'll call this one area 2. We'll work out the area of each and we'll add them together. Area 1 is a triangle, so we're going with the base times height divided by 2 formula, which is going to be 6.8, where I'm getting from here, okay, multiplied by 3.8, all divided by 2. It should give us a total of 12.92 square meters. Area 2 is a rectangle, so we'll go with length times width, which is 6.8 by 8.2, so I'm getting that from here and here, which will give us a total of 55.76 square meters. Okay, that means that the area total will be area 1 plus area 2, which will be 12.92 plus 55.76, giving us a total of 68.68 square meters. Question 1D is asking us to find the area of this composite shape. We've got a square and it's got a missing semicircle, half circle. We don't have enough information yet. We know that this is a half circle through here, but we've got the diameter, and what we'll be looking for in our formula is the radius. So we know that the radius from the center to the outer side of the circle is half the diameter, so this will have a radius of 11 centimeters. And we know these sides are both 22 as well, because these little dashes indicate that they're all the same length. Alright, we'll go in and call it area 1 and area 2. And ultimately what we'll be doing is area 1 minus area 2 to find the total area of this shape here. Okie doke. Area 1 is a rectangle of sorts. A square is a form of rectangle. So we're using length by width, which is going to be 22 times 22, which is 484 square centimeters. Area 2 is half a circle. Okay, so we're going to use the area of a circle formula, pi r squared, but we will be dividing by 2. So that will be pi times 11 squared, all divided by 2, running out of room, which gives us 190.07 square centimeters. Okay. Our area total will be area 1 minus area 2, which will be 484 minus 190.07, which will give us 293.93 square centimeters. Question 2a is a volume question. So this time we're looking for either how much this shape can hold, or how much physical shape how much space this shape takes up. So it's a three-dimensional shape. often where people will come unstuck is trying to actually just visualize this shape and exactly what's happening in it. So in this shape, if you have a look, this triangle here is the base that's flat on the ground and it's standing up vertically. So the other triangle is actually sitting on top, okay? So this is the top of it. Now, in this instance, you can actually go to your formula sheet and there's a formula for the volume of a triangular prism, but you don't need one. With all of these prisms, if you just go looking for the area of the unusual shape, you can then just multiply it by the height of the shape. So if we work out this area and then multiply it by 6, that will give us the volume of this shape. So you can use the formula. It's volume equals the area of a triangle multiplied by the depth of the shape. But that's all it's saying, okay? So we're looking at the area of the triangle and then multiplying it by how tall the shape is. So remember that this is actually the base number for the triangle, so that will represent B, and the height will be 6.5. This information is just disinformation. You don't want to use that. So let's go in and solve it. We've got a base of 14 and we've got a height of 6.5 divided by 2 multiplied by the depth of the shape, which is 6. And if you pop that in your calculator, you'll find that it's 273 cubic millimeters. Now the units are really important here. Previously, we've been working out areas in question 1. They are units squared. Now that we're in volume, it is units cubed. Question 2b is another volume question, and this one is a rectangular prism. So again, you have a formula sheet, and you can use your formula sheet. The formula is volume equals length times width times depth. But as I said in question 2a, you don't really need a formula at all. If you just work out what one of the rectangles is, you can then multiply it, as in the area of this, you can then just multiply it by how deep the shape is. So it's saying a rectangle, the area of a rectangle multiplied by how deep the shape is. So all you need to do is substitute the 3 values in, and that will give you an answer of 122.84 cubic centimeters. Again, being careful of our units. Okay, question 2c is a volume question, and so it's asking you for the volume of this cylinder. Now, just like the other ones, there's a formula for it. So the volume is pi r squared times d. And same as the other ones, what we're really doing here is we're just working out the area of the circle, so the area of the base, and then we're multiplying it by how deep the shape is to convert it into volume. Now be careful, it chases the radius here, and what you're given is the diameter, so it's actually half the diameter, so it's 10 meters that I'm chasing. I'll cross that out so I don't get confused. So we'll sub it in. That means that we've got pi multiplied by 10 squared times a depth of 13, and that will give me the answer 4,084.04 cubic meters. Question 2d is a rectangular prism, so we're going in with the formula volume equals length times width times depth. In other words, the area of a rectangle multiplied by its depth. So sub the values in, we've got 4.1 by 11.6 by 1.9, and that will give us the answer 90.36 cubic meters. Question 3a is asking us to find volume and surface area of these three-dimensional shapes. So this is going to be fairly long-winded. Now, if you have a look at the answer sheets on JC, the solution to that one is by when you're finding the volume, finding the volume of this, if it were an intact rectangular prism, subtracting this rectangular prism from it, it's a good way to do it. I'm going to do it a different way here so that you've got two strategies. In this instance, I'm going to first need to find all this unknown. There's a lot of unknown information here. So this can be 4.7 millimeters, because 4.7 plus 1.3 is 6. And I'm getting that from here, they're equal. I know this side, so I'm okay here. The 6 obviously relates to this side here, and this is an unknown, so this is going to be 7 plus 1.3, so this side here is going to be 8.3 millimeters. And now I think I've got all the information that I need. I can start having a look at solving this. So I like to break these up into two rectangles and call them area 1 and area 2. And what I'm going to do is I'm going to find the total surface area of this two-dimensional shape and then multiply it by the depth in order to turn it into volume. Okay, a little bit like I've explained in previous questions. So area 1 is a rectangle, so length times width. So I'm going to substitute in 1.3, which I'm getting from here, by 6, which I'm getting from here, which is going to give me 7.8 square millimeters. Area 2 is going to be length times width, because it's also a rectangle, so it is going to be 7 by 1.3, so 7 by 1.3, which is going to give me 9.1 millimeters. That gives me a total area of area 1 plus area 2, which will be 7.8 plus 9.1, which gives me 16.9 square millimeters. Now the question doesn't want to know what the surface area of the front is, it wants to know what the volume is, but this particular piece of information is going to be useful to me later, and we'll see why. So the volume is going to be my total area multiplied by how deep the shape is. So in other words, that will be 16.9, so all this area here, multiplied by how deep the shape is, which will be 84.5 cubic millimeters, not to get confused because now we're talking about volume. Alright, so we've solved our volume, we've got half the question done and half of our marks. Now we need to move on to surface area. And in order to think about surface area, I think I'm going to start breaking this shape down a little bit, okay? This won't be ultimately necessary on every single question, but you might remember that way back when you first started learning about 3D shapes, your teacher may have got you to fold nets of shapes. So I'm going to just start with a net, and I'm going to start by using, let's say, this piece here, okay? So this is going to be a rectangle, and it's going to have these weird shaped, composite shaped wings hanging off the sides of it, okay? And then I'll draw in the base. So this would be the piece that would fold up against this, and then I'll do a little one at the top because that one would fold over the back there. Then we've got the underside, so we'd have to do the little piece first. That would fold up against here, and then we'll do the section across here. Then we'll do up this way. And that should be all the sides of our shape. So if you have a think about that, these are the area totals, if you like, okay? They were the ones that we've worked out here. Now, we know how wide the shape was. It was 5 millimeters wide And what we need to do now is we need to come up with some way of working out what the total surface area is. So obviously it's going to be this area plus this enormous rectangle here. And we've got these areas. We know what these are. We know that this one's going to be 16.9 and we know that this one's going to be 16.9. But we don't know what the length of this side is. And this is where we can kind of use a bit of a hack that's quite useful on these questions, because we have actually got all the information that we need. We just need to work out what the perimeter of this shape is, because this wraps around it. So we can go along and we can work out what they are. Remember we started here with this side, so that was 8.3. And then above that we had this side, which was 6. And then we had the little cap on the top, which was 1.3. And then down here we had the little cap, which was 1.3. Then we had our 7 meter side, and then we had our 4.7 meter side. Okay, so if we add all of those up, then we'll know what our rectangle are. So what we might do is we might propose our own formula here. Okay, what we might do is give them some names as well. Okay, so we might say that we've got AC, which is the area of the composite shapes. Okay, we've got the P value, which we might make the perimeter of the composite shapes. And we might call the depth the depth. That makes sense. Then we aren't changing the formulas too much. Which means that the surface area of this should be the perimeter of, so I'm thinking this being the first area, right? So if we do the perimeter times the depth, that will give us this line multiplied by this line. So in other words, that gives us the nice first rectangle. And then all we've got to do is just tack 2 of those weird composite shapes on. So if I do this total area plus 2 of these areas, I should have the surface area of this shape. So let's put them all in and see what happens. If I put in the perimeter and I add all those up, I'll get 28.6 multiplied by the depth of 5 plus 2 times the area of the composite shape, which was this one, okay, 16.9. It should give me 143 plus 33.8, and that will give us a grand total of 176.8 square millimeters. Now just again, remember the units. Surface area is an area, it's not volume, so this is as if you were planning to paint this shape or something along those lines, so make sure you get your units right. Question 3b is asking us to find both the surface area and volume of the cylinder. So there are formulas for both of these on the sheet. So we'll start with, on your formula sheet, so we'll start with the volume. The volume is pi r squared times d. Okay, now just remember that just means the area of this circle multiplied by the depth, as I've said many times. Now we don't have the radius, again they've given us the diameter, so we'll cross that out. What we really want is just the radius, okay, and the radius is going to be half of 9.7, so 4.85 meters. Right, let's sub it in. So we've got pi times 4.85 squared multiplied by 8.1, which if you pop in your calculator will give you 598.57 cubic meters, okay, remembering its volume. Surface area formula is 2 pi r times diameter plus 2 pi r squared. Now it's a long formula, but if you think about it, what this is really saying to you is the circumference, okay, the perimeter of the circle multiplied by the diameter. And that makes sense because if we redraw this as a net like we did with the last one, remember you've just got a rectangle that is wrapped around two circles, okay? So this is saying the circumference of the circle, so this line here, that's this part of it, multiplied by the diameter, okay? And two circles, okay? So two circles, that's the area of these. So we've got 2 times pi times 4.85 times 8.1 plus 2 times pi times 4.85 squared. Pop it in your calculator and you'll get 394.63 square meters. Question 4 asks you to find the volume and surface area of a square prism. It's giving you some dimensions, so maybe it's best just to start out by drawing this. So it says it's standing 88 meters tall, so the square's obviously on the bottom and top. So let's just draw one so we know what we're working with. Okay, so if it's a square prism, that means that these sides are always the same, all the same, and they're 62 meters, and it has a height of 88 meters. Alrighty, so let's work out the volume first. The volume is going to be the length times the width times the depth, which is going to be 62 by 62 by 88, which will give us a total of 338,272 cubic meters. Surface area. The surface area of a rectangular or square prism is, by formula, and then we'll break it down, 2 lots of the length times the width. And then you've got 2 lots of the depth times the width, and then you've got 2 lots of the length times the depth, okay? Now, that makes sense. What you've really got, if we again break this down so that we've got a nice net of it to have a look at, we'd have, oops, four of these rectangles with some little squares hanging off the sides. Oops, that's a pretty bad square. Okay, so if we call the squares 1, we call this side 2, we call this side 3, that makes sense because that would be 1 and the opposite side would also be 1. If we look at 2, so this one's 2, then its opposite side is also going to be 2, and if we've got 3 here, okay, so basically what we've got is we've got a pair of 3 different sides, and that's what this is saying, okay? So it's saying 2 of them, 2 of them, and 2 of them. Now, when you go to put these numbers in, all you really have to do is make sure that the numbers all do a round robin. In other words, you go 62 by 62, okay? And then we go 62 by 88, okay? And then we go 88 by 62. And so long as they all do a round robin, you'll get the right answer. Put it into your calculator, and not forgetting the brackets, and you will get 29,000 rather 512 square meters. Question 5 is asking us to find the volume and surface area of this composite shape. Now, if this doesn't make sense, perhaps go back and watch how we solved question 3a, because that will give some hints, and we use the same sort of strategies to work out the surface area of this one. The volume's pretty straightforward. There's two ways of doing it. You could do it as a square prism, and then you could take away half a cylinder from it. I'm not going to do that. I'm going to use the same system as I used in 3a, because once I've found the area of this composite shape, it will help me with the surface area later on. So let's have a go at, first of all, doing the volume of this shape, okay? And I'm going to do that by working out the surface area of this end and then multiplying it by how deep the shape is. So I've got a square, I know that because these sides are all the same. I'm going to call that area 1. And then I have a half circle, which I'm going to call area 2. And at this stage it's just a two-dimensional shape. I'm only interested in this section here. I'm ignoring that it's 3D. I don't know the radius, I'll just quickly work that out. If this shape has an overall diameter of 5.4, that would make the radius 2.7 meters. So we'll use that as our starting point. Now, all we need to do is do the area 1 minus the area 2, and I'll have the total area. So, area 1 is going to be length by width, which is going to be 5.4 by 5.4. Okay, so 5.4 by 5.4, which is going to be 29.16 square meters. Area 2 is half a circle, so I'm going to halve the circle formula, and so I'll pick that up as pi times 2.7 squared divided by 2, which gives me 11.45 square meters. Alright, that gives me a total area of area 1 minus area 2, 29.16 minus 11.45, which gives me a total of 17.71 square meters. Okay, now this particular value here is going to come in useful later on when I do the surface area, so I'm just going to put a little asterisk next to that one just to help myself remember. That means that the volume of this shape is going to be the total surface area of my composite shape multiplied by how deep my shape is, or 17.71 multiplied by 12, which gives me 212.5 cubic meters. And I might make this really clear to my marker that that's what my volume is that I'm chasing. Now it's time for me to move on to surface area. And so what we're going to do is what we did in question 3a. And although in a test with practice it's not necessary, I will just quickly draw this as a net, just so that it's nice and clear what I'm talking about. I'll start with this side just here, okay? Which means that they'll have these funny little composite shaped wings hanging off the side of them, if you like. And then I'll do this side and the opposite side, so the one in there. And then I'm going to do this underside, so the bit that you can see here, okay, that area would be quite big because it follows the curve of the circle, okay. Okay, we'll just fill in quickly the information that we know on the net. We know the width is 12, and we know this one's going to be 5.4, we know this one's going to be 5.4, we know this one's going to be 5.4, okay. And we don't know what this one's going to be, okay. This one is going to be the circumference of half the circle, okay. So we'll just do that as a little mini sum here, okay. We know that we can work out the circumference by 2 pi r, and if we do half of that, that means that, so we'll call that one x, just so we're not being messy, 2 times pi times 2.7 divided by 2, which is going to be 8.48. So this one here will be 8.48 meters. So we've found all the information that we need. We know the area of these, we found them already, and there's 2 of them. And then we know that this is just a rectangle, the perimeter of this shape, which is this line, multiplied by this to give us this area in here. So if we can do the total area of this, plus this, we've managed to find the surface area of the shape. Now, what we did last time was we said the surface area would be the perimeter of the composite shape multiplied by the depth plus 2 times the area of the composite shape. And that's just too much to write, so we made up some letters for it. So we said that the surface area was the perimeter of our composite shape multiplied by the depth. Okay, so the perimeter multiplied by its depth plus 2 of these guys, areas of composite shape. And then when we sub all of that in, we get all these strung up again. So we get 8.48 plus 5.4 plus 5.4 plus 5.4, I'm taking these from here, multiplied by 12. So that times that, which takes care of that part of the equation, or that rectangle, plus 2 times the area of these guys, which remember was the one that we saved the information about, 17.71. And if you pop that into a calculator and start breaking it down, that would be 24.68 multiplied by 12 plus 2 times 17.71, or a grand total of 331.6 square meters this time. I guess we're talking about surface area.